My dear students, in previous class we have learned some properties of determinant. Today in this class we will discuss some numerical problem from exercise 4.2. So let's start question number 3. Question number 3. Two, 7, 65, and second row the elements are 3, 8, 75, 5, 9, 86 equal to 0. Prove that by using the properties of determinant. Prove this equal to this. Solution. Left hand side equal to is a 3 by 3 order determinant. The first row elements are 2, 7, 6, 5, and the second row elements are 3, 8, 75, and the third row elements are 5, 9, 86. Applying C2 tends to C1 tends to C1 plus 9 into C2. If you apply C1 tends to C1 plus 9 to C2, that means the first column, C1 means first column, tends to first column plus 9 into second column is equal to C1 tends to C1 plus 9 to C2, C1 2 plus 9 into 7, 63 plus 2, 65 for these elements, 3 plus 9 into 8, 72, 72 plus 3, 75, and for these elements we have 5 plus 9, 9, 81, 81 plus 5, 86. The second column does not change, 7, 8, 9, and third column does not change, 65, 75, 86. Here, the first column and third columns are identical. Here, the first column and third columns are identical. We know that if two rows or columns are identical, the elements of two rows or columns are identical, then the determinant is equal to 0. This equal to 0 equal to right hand side. Hence proof. Since first column and third columns are identical, therefore this equal to 0. Next, question number 8. 8.1. The first row elements are 1a square, 1b square, 1c square is equal to a minus b minus c, and c minus a. Using properties of determinant, prove this equal to this. Solution. Left hand side equal to 1a square, 1b square, 1c square. Right hand side, here the right hand side equal to a minus b into b minus c into c minus a. For a first factor a minus b, if we apply r1 tends to r1 minus r2, if we apply r1 tends to r1 minus r2, then we have 1 minus 1 0, a minus b, and this is equal to, this value becomes a square minus b square, that is equal to a plus b into a minus b. So applying r1 tends to r1 minus r2, this then this equal to 1 minus 1 0 and a minus b, this equal to a square minus b square, a square minus b square is equal to a plus b into a minus b. Next element, the next second row does not change, 1 b b square, next 1 c c square. Now taking common a minus b from r1, now taking common a minus b from r1, taking common a minus b from r1, and then we have this equal to a minus b is 0, here a minus b is here 1, and this equal to a plus b, 1 b b square, 1 c c square. Next, applying for this factor, applying r1 tends to r2 minus r3, applying r2 tends to r2 minus r3, then we have a minus b 0 1 a plus b, r2 tends to r2 minus r3, 1 minus 1 0 b minus c, b square minus c square, this equal to b plus c into b minus c. Next 1 c c square. After applying r2 tends to r2 minus r3, then we have a minus b into determinant this. Now taking common b minus c from r3, taking common b minus c from r2, then we have taking common b minus c from r2, we get a minus b into b minus c into 0 1 a plus b, next 0 this 1 and b plus c 1 c c square. After common b minus c, then we have this. Now the first column, the two elements are 0, then the expanding along C1, we have now expanding along C1 means first column, then we have a minus b into b minus c into this equal to 0 plus 0 plus for these elements minus 1 whole power. These elements belongs to third row first column, therefore minus 1 whole power 3 plus 1 into the element of A31 1 into deleting this row and these columns, the remaining elements are 1 a plus b 1 b plus c. Bracket close. This equal to a minus b into b minus c into minus 1 whole power 4. Minus 1 whole power 4 is equal to 1. 1 into 1 1. Next 1 plus b plus c. 1 plus b plus c equal to b plus c minus 1 into a plus b equal to a plus b. Next a plus b into b minus c into b plus c minus a plus into minus minus into plus minus minus into plus minus. plus b minus b cancel, a minus b, b minus c into c minus a, which is equal to this, equal to right hand side. Next, question number 10(1). Question number 10(1). Here, x plus 4, 2x, 2x. Next, 2x, x plus 4, 2x, 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 x plus 4. This equal to 5x plus 4, 4 minus x whole square. Left hand side solution. Left hand side equal to x plus 4, 2x, 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 x plus 4, 2x, 2x, 2x. The left hand side equal to, the first row elements are x plus 4, 2x, 2x. The second row elements are 2x, x plus 4, 2x. The third row elements are 2x, 2x, x plus 4. If we applying R1 tends to R1 plus R2 plus R3, then we have applying R1 tends to R1 plus R2 plus R3, then we have x plus 4 plus 2x plus 2x, 5x plus 4, 2x plus x plus 4 plus 2x, this is equal to 5x plus 4, this is equal to 5x plus 4. Next, R2, R3 does not change, 2x, x plus 4, 2x, 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 x plus 4. Next, taking common 5x plus 4 from C1. Here, taking common 5x plus 4 from R1 first row. Taking common 5x plus 4 from first row, then we have 5x plus 4 into determinant 1, 1, 1. Next, 2x, x plus 4, 2x, 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 x plus 4. After taking x plus 4 from R1, then we have this. Next, if we applying C1 tends to C1 minus C1, C2 tends to C2 minus C1, then we have C2 tends to C2 minus C1, then we have 5x plus 4 into C1 does not change, 1, 2x, 2x, C2 tends to C2 minus C1, 1 minus 1, 0, x plus 4 minus 2x, x plus 4 minus 2x, this is equal to 4 minus x, 4 minus x, 2x minus 2x, this is equal to 0, 1, 2x, x plus 4. Now, taking common here, the second column, the elements are 0, 4 minus x, 0. Therefore, taking common 4 minus x from C2, then we have taking common 4 minus x from C2, then we get 5x plus 4 into 4 minus x into 1, 2x, 2x, 0, 1, 0, 1, 2x, x plus 4. After taking 4 minus x from C2, then we have this. Next, expanding by using C2. Here's the maximum elements are 0. Here, two elements are 0, therefore expanding along C2, then we have expanding along C2, we get 5x plus 4 into 4 minus x into expanding along second column. For these elements, minus 1 whole to the power, these elements belongs to first or second column, therefore minus 1 whole to the power 1 by 2 into the elements a12 is equal to 0, therefore 0. And next, deleting this row and these columns, the remaining elements are 2x, 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 x plus 4. Next, for these elements, minus 1 whole to the power, these elements belong to second row, second columns. Second row, second column, therefore minus 1 whole to the power 2 plus 2. And elements, the A22 elements is 1, therefore here 1. Next, determinant, deleting this column and this row, then the remaining elements are 1, 1, 2x, x plus 4, 1, 1, 2x, x plus 4. Next, for these elements, minus 1 whole to the power, this element belongs to third row, second column, therefore minus 1 whole to the power 3 plus 2 into 0. And deleting this column and this row, the remaining elements are 1, 1, 2x, 2x. Here 5x plus 4 into 4 minus x into, we know that multiplying any number with 0, then the result is 0. 0 into this, the resultant answer will be 0. X plus minus 1 whole to the power 4, minus 1 whole to the power 4 is equal to 1. 1 into 1, 1. Next, for this determinant, multiplying this and this element minus this and this element, therefore we have 1 into x plus 4 equal to x plus 4 minus 1 into 2x to 2x plus 0 into this equal to 0. X 5x plus 4 into 4 minus x into x plus 4 minus 2x, this equal to 4 minus x. Therefore 5x plus 4 into 4 minus x whole square, this equal to right hand side, hence proof. Next, question number 11.1. Question number 11.1. Remember, these exercises are very important for the board exam. Question number 11.1. Proof by using properties of determinant, prove that a minus b minus c, thus for the second elements 2a, third elements 2a, the second row for the elements are 2b, b minus c minus a, and 2b, 2c, 2c, c minus a minus b. This equal to a plus b plus c whole cube. Solution. Left hand side equal to a minus b minus c, 2a, 2a, 2b, b minus c minus a, 2b, 2c, 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 c minus a minus b. Applying R1 tends to R1 plus R2 plus R3, then we have R1 tends to R1 plus R2 plus R3, then we have A minus B minus C plus 2B plus 2C, this equal to A plus B plus C. Next 2A plus B minus C minus A plus 2C, this equal to A plus B plus C. Next 2A plus 2B plus C minus A minus B is equal to A plus B plus C. R2 and R3 does not change. 2B, B minus C minus A, 2B, 2C, 2C, C minus A minus B. Now, taking common A plus B plus C from C1. Taking common A plus B plus C from C1, then we have taking common A plus B plus C from first row, then we get A plus B plus C into determinant 1, 1, 1. Here 2B, B minus C minus A, 2B, 2C, 2C, C minus A minus B. Now, applying C1 tends to C1 minus C2. Now, C1 tends to first column minus second columns. This equal to A plus B plus C into C1 minus C2, 1 minus 1, 0, 2B minus B, 2B minus bracket B minus C minus A, this equal to A plus B plus C, 2C minus 2C, this equal to 0. Next 1, B minus C minus A, 2C, 1, 2B, C minus A minus B. Now, taking common A plus B plus C from C1, then we have taking common A plus B plus C from C1, then we have zero, 1, 0, 2C, 1, 2B, here the maximum elements are 0 on the first column, therefore expanding by using the first column, then we have expanding along first column, and we have is equal to A plus B plus C whole square, bracket start. Expanding along first column for these elements, minus 1 whole power, these elements belongs to first column, therefore minus 1 whole power 1 plus 1, and element is 0. Next determinant, relating this row and this column, we have B minus C minus A, 2C, 2B, C minus A minus B, plus for these elements these elements belongs to second or first column, therefore minus 1 whole to the power 2 plus 1 into the element is 1 into deleting this column and this row, then the remaining elements are 1 1 2 c minus a minus b, 1 1 b minus c minus a, sorry 2c c minus a minus b, plus for these elements minus 1 whole to the power, this element belongs to third row first column, therefore minus 1 whole to the power 3 plus 1 into the elements 0 into deleting this column and this row, the remaining elements are 1 1 b minus c minus a into 2b. Is equal to a plus b plus c whole square into bracket start 0 into this the result is 0 plus minus 1 over 3 minus 1 over 3 is equal to minus 1 into 1 minus 1, this is equal to minus, and multiplying this into this minus this into this, therefore we have c minus a minus b minus 2c plus 0 into this equal to 0. A plus b plus c whole square into minus c minus 2c, c minus 2c equal to minus c minus a minus b is equal to a plus c whole square into plus a plus b plus c, a plus b plus c, this is equal to a plus b plus c whole cube equal to right hand side. Hence proof. Thank you.